So which statement is true regarding the graph function x? So let's look at 6. So basically, find true statement. Okay. And it's saying I have a is an increasing degree, or sorry, f of the function f is an increasing function. It's a decreasing function. F of x tends to infinity as x tends to positive infinity, and f of x tends to negative infinity as x tends to negative infinity. So let me write this out. So a here is increasing function. B here is a decreasing function. C here is a f of x tends to, so as basically it's saying as x heads to positive infinity, f of x also heads to positive infinity. So as, or I'll say as x approaches positive infinity, f of x approaches positive infinity. And D here says that if as x tends to negative infinity, f of x tends to negative infinity here. Okay, so it's asking which statement is true for the graph function below. Okay, so find a true statement. Let's look at 1. 6a here, is it an increasing function? It is an increasing function, but it's from here to here, right? So it depends on what you can specify this as an increasing function only at this point. It's only from like this here would be, I don't know what the x-intercepts are, or I don't know what the vertex here is. I can maybe approximate here. That's -2, I guess is 1. This is from like half, and I'm assuming this is 2.5. So from where x is equal to 2.5 and onwards, so from x equals 2.5 and onwards, it is a increasing function, and from x equals 2.5 and backwards, it's also actually an increasing function actually in this case. Or no, in this case it would be a decreasing function because this value decreases here. So this here is a decreasing function. But however, the entire function is both increasing and decreasing. So in this case, A and B are both wrong, right? Because it's both in this case. So in this case, increasing and decreasing are both wrong, right? Let's look at C here. C here is x approaches infinity, f of x approaches positive infinity. This here is correct, right? Because as x approaches like 4, 6, 8, 10, my graph is going up. Y is going to positive infinity. This here is correct. And if x is heading to negative infinity, f of x is negative infinity. This here is incorrect here, right? F of x should be approaching positive infinity. It's going up here and not down here, right? So this here is also wrong, which means C here is my correct answer. However, I don't really like this question because when you ask what's an increasing and a decreasing function, this here is a decreasing function. It's an increasing function from this period. Basically, the vertex is here. Let me just redraw this, and I'll show you what I mean by how I don't like this problem, or I don't like the questions that they give with this problem here. I'm going to show you the blue one here. So if you have the vertex is like here, for example, this side here is increasing, and then this side here is decreasing. So like the function is both, it's both increasing and decreasing up until this this vertex here. So in this case, like these two questions would have been, it's still the true statement, but this is more true, if that makes any sense at all. That's how you would answer these types of questions here. So C is correct. A is false. A function has to be increasing if g of x of 1 is greater than g of x2 whenever x of 1 is x at 2. So from the graph, observe, so they put f of 2 is here equals f of 3. F of 3 would be here equals 0. That means 3 is greater than 2, but f of 3 is not greater. 3 is greater than 2, but f of 3 is at 0. F of 2 is here, f of 3 is. F of 2 and f of 3 are both of these guys here are 0, but 3 is greater than 2, so it's not an increasing function. The function g is set to be increasing whenever this condition meets, and they're doing the exact same because 2 is less than 3, so it's not greater. Okay, so C is true, D is false. So I don't really like the explanation for this here, because in this case, you have a vertex here. It's a parabola, clearly. And what they're doing is this function decreases up until this point, and this function increases up after this point, right? So, like, technically, it's not false, but there should be a condition. It should be an interval. It should be like negative infinity. If I were to draw out the intervals of increase, I can say this is from 2.5 towards positive infinity, and then decreasing would be negative infinity to 2.5, right? There's an interval of increase and decrease. So I'm going to say great solution. However, explanation for increasing and decreasing functions can also be supported by stating the intervals of increase and decrease. So you can say that increasing function, and so square brackets, so this is 2.5 to infinity, and then decreasing function from negative infinity to 2.5. So this here would support the argument here.